This is what we're going to go over today. We'll cover the changes in the enterprise data landscape with a quick overview on where object storage fits into the broader network storage market. Then we'll go over 3 macro business issues that object storage addresses. And to wrap up, we'll go over some recent use cases and trends we're seeing in the market. Again, I'm going to try to keep this under 30 minutes if possible. So it's no surprise to anyone that the enterprise data landscape is changing. Again, depending on which analyst you believe, there's going to be 70 to 40 zettabytes of data by 2020. And the majority of this information is going to be unstructured. So compounding this issue is the expectation of users to store everything they create and access it forever from any device. Again, we call this cloud conditioning, and it's all about getting the information you want on demand when you want it. Adding yet another layer of complexity is the unpredictable nature of access. Access is now going to come directly from applications over the web by potentially millions of users with unpredictable access patterns. Today, access is still coming through standard storage protocols, but as we'll see in a bit, that's changing, especially for some of today's web scale applications. On their own, each of these is a significant issue for IT administrators and business managers. But let's take a look at what this really means from an overall data perspective. So instead of sharing this standard hockey stick data growth slide, I like to show this slide. This is what happens in an internet minute. If you want a closer look, just do a Google search for Fresh Info's Internet Minute, and you'll be able to really blow this up to a larger scale on your screen. I know it's kind of hard to read here. But these are arguably the fastest growing applications in the world. Most of them have created proprietary infrastructure solutions out of necessity. And this is a comparison of their growth from 2013 to 2014. They're really experiencing web scale growth and need to ensure user experience and instant access, or their businesses will suffer, and they could possibly disappear just as fast as they appeared. Did you know that Instagram and Pinterest were founded in 2010 and Vine was founded in 2013? From a storage perspective, a standard storage refresh cycle is anywhere between 4 to 5 years. Some of these organizations didn't even exist 3 years ago. The point is, you really don't know what apps will need to access your data even a year from now. Just look at Instagram's growth in 1 year, 76% more photos uploaded per minute. I'm sure this is a lot higher now. The point is, a lot of information flowing through these networks is now enterprise data, including all of the assets that businesses post on these social networks, all the demographic information, all the user behavior log files, advertising, etc. The nature of enterprise data and data access patterns are changing. Now let's take a look at current storage technologies that store all this information. Here are the 3 main network storage technologies. On the left, you have object, then file, then block. We'll start with a description of object. Object storage is based on key value addressing. You store an object and you get a key. It's very similar to the way car valet works. So you give them your car, you get a ticket, they park your car, you don't really care where it is, you just care that you get it back. You give them your ticket, you get it back. The client or access method is usually an application over HTTP, and system or custom information about the file is stored in metadata. Object is ideal for shared, infrequently changing files and for scalable multi-site deployments. Then you have file. So in file-based storage, a file system manages directories, files, and storing on disk through inodes and blocks. Because of the use of inodes, there are finite limits to many file systems, and most have problems scaling beyond the petabyte range and have problems scaling beyond billions of files. File-based storage is usually accessed via standard protocols like NFS or SMB. Fixed file attributes like type, size, date created, date modified are stored in the file system. File-based storage is good at shared files and shared directories over LANs and WANs, and does come with some benefits like file locking to make sure that collaboration is a bit easier over LAN and WAN. Now, there are some cloud-based file services emerging, like Amazon Elastic File System and OpenStack Manila, but they're still relatively expensive or still in development. Then we have block. In block, data is organized as an array of blocks. You carve out a portion of these blocks to form a volume that can be formatted as a local block device. Access for block storage is usually through a client on the operating system over Fiber Channel, iSCSI, or AT over Ethernet, or some other protocol. Fixed system attributes are stored with the block. And block is ideal for transactional or structured information like databases or running virtual machines, and is optimized for performance and is usually measured in input-output operations per second. Now that we've established some network storage technology options, let's look at the business issues driven by the changing landscape of enterprise data. So the graph shows what we at Caringo have seen over time at various organizations. When we first launched our storage software in 2006, IT budgets could still handle the price, capacity, performance mix offered by file-based and block-based storage devices like NAS and SAN. But last year, we experienced a noticeable increase in interest in object storage in general. Data growth and limitations in traditional technologies were starting to stutter at the petabyte capacity range, and for many companies, growth is only increasing in momentum. Add to this the effect of the cloud, with users expecting always-on and accessible storage and access from new web-based applications, and the market of rapidly growing data set, of organizations facing rapidly growing data sets, started to see the writing on the wall. What worked for them in 2006 or even in 2013 wasn't going to work for them in the very near future. Their budgets just aren't increasing at the rate of data. This is a textbook indicator that you need to do something new altogether. What many of our existing customers did is start looking at how web scale companies, the guys on the infographic I just showed, stored their data, and that led to them looking into object storage and Caringo. Now let's take a look at the second business issue. On the left-hand side, you have capacity. At the bottom, you have price, and on the right-hand side, you have local or web-based access. You can see where object storage fits in from a capacity, cost, and access perspective versus SAN and NAS. From a cost perspective, SAN is around $2 to $3 per gigabyte. NAS is around $1 per gigabyte, and object can get to well under 30 cents per gigabyte. And this is at scale, in large scale deployments. And it's just a rule of thumb. Prices vary tremendously depending on vendor. Most analysts will agree that the lion's share of growth is happening in unstructured data, and that most of this data needs to remain accessible and searchable to drive productivity and business agility. So this is the new opportunity for object storage within the data center. If you want reliable, scalable storage over 1 petabyte that's instantly searchable, then object storage really is the only practical way to get there. You'll notice the SAN market is still there. There are some very high performance, low latency applications that you really still need to use block storage for. But as we'll show, the opportunity for object is overflowing into some traditional NAS use cases. Now, let's take a look at the effect of software defined. Now, we at Caringo define software defined in the purest nature of the term. So actually installing software on hardware and virtualizing those resources. There's others in the market that define it as a management layer, still with legacy applications underneath. We feel you don't really get the true value of software defined if you're not virtualizing those resources completely, not just from the management perspective. So what we're seeing on this slide is all prices are shifting to the right. So I'll go back so you can see that. All prices are shifting to the right. And that's because of the use of commodity hardware. In addition, the market for traditional NAS appliances is eroding because of software NAS options. Object storage is also chipping away at NAS use cases, as we'll see later in the presentation. Because object storage software is so adaptable, you can use commodity hardware with higher performance characteristics to meet a subset of traditional NAS workloads. And as we saw in the previous graph, the overall opportunity to use object in the data center is increasing, ultimately making your IT budget go a lot farther while increasing business agility and overall productivity. Now let's take a look at the third business issue, risk. From the storage perspective, risk can come in many forms, but there are high-level reasons we are seeing companies move away from traditional storage technologies and even some software-defined storage solutions. The first element of risk are complexity and cost. Many traditional solutions or even some new open source solutions are very complex to deploy or cost prohibitive due to the rate of data growth. The second elements of risk are limited scale and single points of failure. As mentioned before, many traditional NAS solutions start to have issues beyond the 1 petabyte and can't scale over 2 petabytes in one location. Many organizations are approaching and exceeding this limit. Also, some software-based solutions introduce single points of failure. And if one of those single points of failure goes down, you can compromise data access or even compromise the data. The third element of risk is siloing data or locking it into a single location, limiting the ability for reuse and analysis. This is really a big issue in big data, life sciences, and medical imaging use cases where sharing information can literally be a matter of life or death. And last, but certainly not least, is the risk of data loss. As we'll see when we go over the use cases, the complexity of file-based solutions at scale led to lost data for some of our customers. Now let's take a look at how the ideal object storage solution can solve these different elements of risk. These architectural approaches and methods are what you should look for in an object storage solution that focuses on reducing risk. The first is all-inclusive software. When you're rapidly scaling, you need to be able to just plug in additional hardware and boot from bare metal. You don't want to mess with installing operating systems, patching, or running complex script automation. All nodes should perform all processes. Beware of controller nodes and other specialized nodes. At the multi-petabyte level, these will become difficult to manage in size. When all nodes do the same thing, all processes get faster as the cluster grows. Along the same lines, metadata should be stored with the data. If it isn't, you create a single point of failure and limit the ability to continuously optimize the entire cluster. And finally, look for ease of protection. In object storage, there are two ways to protect data: replication, which is creating additional copies, and erasure coding, which splits data into multiple segments where you can lose a certain number of segments and still get your data back. You should be able to store replicated and erasure-coded objects all on the same nodes and seamlessly shift between one protection method to another. Now, let's take a look at how object storage is driving use case agility. So the native interface for most object storage solutions is a RESTful interface over HTTP, and many solutions offer SDKs for all major languages. Caringo Swarm, our object storage solution, also supports the Amazon S3 API, and we have a plugin for OpenStack Swift. We also have different file system interface options, both internally developed and through partners. In addition, we have a block interface. We also have a Hadoop plugin that plugs straight into your Hadoop cluster. And we work with a number of different sync and share applications. Now, the value here is leveraging the same easy-to-manage infrastructure for a wide variety of use cases by selecting the interface and optimizing for specific workloads through the use of different commodity hardware. For example, if you have an archiving use case, use a file system interface with dense storage on the back end. If you have a big data use case, use the Hadoop interface with higher performance servers and less dense storage. The best way to show this is by walking you through a few recent use cases. So the first is medical imaging. This is for the Department of Defense. It's a medical image consolidation for the armed forces, the Army and Navy. They started out at around 6 petabytes, and now they're closer to 10 petabytes. They have some pretty stringent storage requirements from a governance and long-term storage perspective. There are hundreds of geographically dispersed sites around the world. The way that they're using object storage is through a vendor-neutral archive application that has directly integrated access to Swarm via the HTTP API. And that really is the best way to integrate access. You're going to get the most performance, and you're also going to get the most value of our standard feature sets if you integrate directly to our API. And now the trend here is eliminating storage silos and value through accessibility. This is something that exists in every healthcare service around the world. Storage silos are still around. And by moving to object storage, you enable low-cost, high-scale, cloud-based clinical archiving. There's significant investment protection and SLA differentiation here, meaning that you can continue to optimize hardware as it becomes more efficient by just plugging it in and retiring the old hardware. The next trending use case is web content delivery. So 2.com is now actually part of the IAC network. And in addition to 2.com, we work with other IAC products like Match.com. But we do have a use case that goes into detail on how 2.com is using Swarm. There's really millions of variable sized photos. They use SSDs for their thumbnails, and they use cost-effective SATA for their larger, higher quality images. That really shows how you can use different hardware underneath the same software to optimize for your workload or use case. They're moving data off of file system-based, another object store that didn't scale to their needs, onto Swarm. The trend here is using cost-effective infrastructure enabling an ad-based service. So when you're dealing with an ad-based or a free service, cost and user experience is key. You cannot give up your user experience, and you can't have your infrastructure cost too much. Otherwise, you'll just go out of business. You won't be able to support your infrastructure. So what happens with Swarm is they're able to reduce the price per terabyte by more than 20%. They don't have to invest in 10 gig Yi or iSCSI network. They just use their regular Ethernet. And it was easy to set up, self-healing, pay-as-you-grow with no huge upfront investment. So there was some really, really great cost savings and features that they got out of Swarm. The next trending use case is one that's really hot right now in the market. It's evidence storage. So if you turn on the news, you'll hear about body-worn cameras, and this falls into that category. We're actually storing all of the in-car video footage for the city of Austin for their police cars. They started at around 2 petabytes with a projected growth to around 10 petabytes within just a few years. So the patrol cars are capturing the video. There's about 650 vehicles. They're actually moving data off of NetApp filers onto Swarm because the NetApp filers just couldn't scale to the level that they need them to. Now, this is, going back to the graphs that I showed, this is where object is really starting to take over some traditional NAS use cases. And not only do they get the value of lower cost, higher reliability storage, they also get the accessibility features like direct accessibility over the web, and also the ability to store custom metadata, which they can then analyze at a later date. So the trend we're seeing here is cost-effective private cloud infrastructure. So they actually saw the writing on the wall, and they went and they started researching how Amazon, how Google, how YouTube and others were storing their information, and that led them to object storage and ultimately Caringo. And this is a use case that exists in nearly every city and every county in the world. The first wave of this was in-vehicle body-worn video was just going to compound this issue for many municipalities in the world. And they're going to have to make a decision. Do they use a cloud-based service, or do they bring this on-premise? For most medium to large municipalities and departments, it's going to make more economical sense to bring that on-premise. Another trending use case is big data. This specifically here is a Splunk use case. We can't tell you who it's for, but it's for one of our larger customers. The Hadoop logo is there because we can do the same with Hadoop, but this is a Splunk use case. So it's for log file analysis. So they have 2 sites over 1,000 miles apart. They're storing log files, which they then analyze for specific information. Now they're moving data off of Isilon onto Swarm, and they're doing a direct integration. I should mention the City of Austin was using a file system interface to move data off of NetApp, and here this organization is moving data off of Isilon onto Swarm through a direct integration. A reason they needed to scale over 2 petabytes per location, and the manual management of the Isilon solution just was too difficult, and there was actually some lost data that occurred. And they all had another requirement that the solution needed to be software-based so that they can deploy it rapidly in different locations. So if you have an appliance, it'll take some time to get that appliance to a geographic location. With a software-based solution, you can have standard commodity hardware already racked in your data center, and if something goes wrong, just shoot over the bits or download the code, boot from bare metal, and off you go. You have another cluster. Now, the trend here is instant analysis with stringent retention requirements. So we beat out all other players because we're really bulletproof. And it goes back to some of the characteristics I showed earlier. The all nodes do the same thing, Swarm architecture, along with the ease of protection and continuous protection. There was significant TCO reduction, and the metadata approach enables writing native analysis and applications. And we'll see metadata playing a more important role in object storage and data analysis. It already is, but in the near future, it's even going to become more important. Another trending use case is cloud storage. So we power the cloud storage service for Telefonica. They're a large global telco with many locations around the world. They started with just a few hundred terabytes, but they're growing to multiple petabytes in various locations. Now, they're using our software to provide public and private cloud storage services, and they're using the enterprise features and the ease in protection to provide different SLA packages. So that's how they're differentiating. They're providing SLA packages, and they're also leveraging some of the compliance features that come standard in Swarm. They're also using the S3 protocol that we provide, the S3 protocol support we provide, in order to take advantage of the ecosystem of applications that are already out there. So the trend we're seeing here is private cloud and cross-border data security. So for a lot of international organizations, they have some concerns using services located in the United States because some of the regulations we have here. And that's leading them to stand up their own solutions within their own data centers. And Telefonica is actually managing those solutions for some of their larger customers, either within their own data center or on-premise. So to wrap up, instead of the standard summary slide, I just wanted to share some of our customer quotes on the value they get from object storage, specifically Caringo Swarm. Now, these quotes all fall under solving the business issues I discussed earlier. From a cost containment perspective, a network architect, the City of Austin, mentioned saving at least half the cost versus their traditional NAS-based solution over one refresh cycle, and the ability to continually benefit from the increasing densities of hard drives. So as hard drives, as we get into the world of 8 terabyte and 10 terabyte hard drives, you can literally just plug them in to your cluster, to chassis, and benefit from the increased capacities and increase in power utilization. For improved productivity, the global cloud director at Telefonica mentions using Swarm to differentiate their service offering while scaling globally. So this allows them to improve the productivity and ultimately the feature set that they offer their user base, and helps them compete with the likes of Amazon and others. And for risk reduction, the CIO at 2.com mentions the ability to lose nodes without impact and the ease of adding more capacity and throughput. So in rapidly scaling web scale use cases, keeping up with a big rush of inbound requests or client requests is incredibly important. So, Remember, going back into the presentation where I mentioned needing to have all-inclusive software where you just boot from bare metal and you're able to scale both capacity and performance in minutes. That's really what running or managing your infrastructure like a cloud is all about. It's this just-in-time ease of scale. And you get that with Swarm, and you can see from this quote that our customers are benefiting from that. So that completes the presentation portion of the webinar, and I'm now opening it up to questions if anyone has them.